Welcome to our journey through the cosmos. Before there was something, before there was anything, physicists now believe there was nothing. No space as we know it, no time as we understand it. And then, from this nothingness, came everything. Today, we're breaking down the Big Bang Theory, the cornerstone of modern cosmology. It's the story of our universe, from its fiery birth to its ever-evolving present. We'll explore the mind-boggling concepts that underpin this theory, the evidence that supports it, and the mysteries that still lie ahead. Imagine, if you will, the entirety of our universe, all the stars, galaxies, planets, and everything in between, compressed into a point smaller than an atom. This point, called a singularity, contained unimaginable energy and density. The Big Bang wasn't an explosion in the traditional sense, it was the rapid expansion of space itself, from that infinitesimally small point, carrying all the matter and energy of the universe outward. Think of it like inflating a balloon. As you blow air in, the surface of the balloon expands, and so do the markings on its surface. Similarly, space itself stretched and expanded, carrying galaxies along for the ride. This expansion, which continues to this day, is the defining feature of our universe. It's the reason why distant galaxies appear to be moving away from us. They're not flying through space, space itself is stretching. This fundamental concept is key to understanding the grand narrative of the Big Bang. The very notion of before the Big Bang is a bit of a head-scratcher. Our understanding of time, as governed by the laws of physics, breaks down at the singularity. It's like asking, what's south of the South Pole? The question itself ceases to make sense. However, that hasn't stopped physicists from exploring intriguing possibilities. Some theories propose that our universe could be just one in a vast multiverse, perhaps colliding with other universes or bubbling up from some higher dimensional reality. Others delve into the realm of quantum mechanics, suggesting that the universe could have sprung into existence from a quantum fluctuation, a spontaneous emergence from the fabric of quantum uncertainty. These are just a few of the mind-bending ideas scientists are exploring as we push the boundaries of our cosmic understanding. In the first fleeting fractions of a second after the Big Bang, the universe was an unimaginably hot and dense soup of energy. As the universe expanded, it cooled, and energy began to condense into matter, following Einstein's famous equation, EMC2. This wasn't the matter we know and love today. No atoms, no protons, no neutrons, just a sea of fundamental particles like quarks, leptons, and their antimatter counterparts. These particles interacted at incredible speeds, constantly being created and annihilated in a cosmic dance of energy and matter. Imagine a scene of utter chaos, a maelstrom of particles colliding and transforming at unimaginable speeds. The very fabric of space and time was still in flux, expanding at an unfathomable rate. As the universe continued to expand and cool, the primordial soup thinned out. This cooling was crucial. It allowed the strong nuclear force, one of the four fundamental forces of nature, to take hold. This force binds quarks together to form protons and neutrons, the building blocks of atomic nuclei. As temperatures dropped further, these protons and neutrons began to stick together, a process called nucleosynthesis, forming the first light elements, hydrogen, helium, and a smattering of lithium. These elements, forged in the crucible of the early universe, would become the raw materials for the first stars and galaxies. For hundreds of millions of years after the Big Bang, the universe remained a dark and expanding expanse of mostly hydrogen and helium gas. Gravity, however, was at work. Ever so slowly, it drew these gases together into denser and denser clumps. These clumps, under their own gravitational pull, continued to collapse, their cores becoming hotter and denser. Finally, after eons of cosmic gestation, the temperatures and pressures inside these collapsing gas clouds reached a critical threshold, igniting the nuclear fusion of hydrogen into helium. The first stars were born, blazing with a light that had never shone before. The expansion that began with the Big Bang didn't stop after the first stars ignited. In fact, the universe is still expanding today. And not only that, its expansion is accelerating. We know this because astronomers have observed that distant galaxies are moving away from us, and the farther away they are, the faster they're receding. This discovery, which earned its discoverers the Nobel Prize in Physics, suggests that a mysterious force, dubbed dark energy, is counteracting gravity and pushing everything apart. The nature of dark energy remains one of the biggest unsolved mysteries in modern cosmology. Echoes of the Big Bang evidence for a cosmic birth. The Big Bang theory isn't just a philosophical musing, it's supported by a wealth of observational evidence. One of the most compelling pieces of evidence is the cosmic microwave background radiation, often called the afterglow of the Big Bang. This faint, omnipresent glow permeates the universe and represents the remnants of the intense heat of the early universe, stretched out over billions of years. The pattern of tiny temperature fluctuations in this radiation provides a snapshot of the universe as it existed just 380,000 years after the Big Bang, offering crucial insights into the universe's early structure and composition. The end of the cosmos, fates of the universe. The universe as we know it had a beginning, and it too will have an end. Cosmologists have proposed several possible scenarios for the ultimate fate of the universe, each more mind-boggling than the last. One possibility is the Big Freeze, where the universe continues to expand indefinitely, becoming increasingly cold, dark, and empty, as stars burn out and galaxies drift farther apart. Another scenario is the Big Crunch, where the expansion eventually reverses, pulling everything back together in a fiery collapse that mirrors the Big Bang in reverse. And there's the Big Rip, where the expansion accelerates so rapidly that it eventually tears apart galaxies, stars, planets, and even atoms themselves. The never-ending story: future exploration. Our understanding of the Big Bang and the universe's evolution is a testament to the power of human curiosity and scientific inquiry. Yet for all that we've learned, the cosmos remains a place of profound mystery. What is the true nature of dark matter and dark energy, the invisible forces that govern the universe's destiny? Are there other universes out there, perhaps with different laws of physics or even different dimensions? These are just a few of the tantalizing questions that drive cosmologists to peer deeper into the universe's past and contemplate its future. The quest to unravel the universe's greatest secrets is far from over. In fact, it's just beginning. An everlasting wonder. Thanks for joining us on this cosmic journey. We've explored the mind-bending concepts of the Big Bang, from the universe's fiery birth to its ever-evolving present. We've delved into the evidence that supports this grand theory and glimpsed the mysteries that still lie ahead. Stay curious and keep exploring the wonders of the universe. The cosmos is vast and full of wonders waiting to be discovered. Every new observation, every theory proposed, every question asked brings us closer to understanding our place in this grand cosmic narrative.